In this tutorial, you will benefit greatly from a beginner's request for help with the part he was designing. Designing that part will be fairly simple, but understanding why and how we use constraints is a bigger subject that needs to be learned. Therefore, join us as we will discuss how to use the vertical, horizontal, coincident, tangent, midpoint, and symmetry constraints along with fundamental mathematical expressions in this tutorial brought to you by the Learn It channel. So the first thing we're going to do with this tutorial is I will model the part. This will help you to go back and reference it later, and it will also give you a brief overview of what we're going to discuss in this lesson. Now, the topic of constraints is not something that can be answered easily and instantaneously, but it's something that's very easy once you get it, but it needs to be explained, and I hope to do that with this tutorial. So let's get right into it. Again, I'm going to model it first of all, and then we'll get into the nitty-gritty of explaining exactly why we use constraints, the benefits of it, how that applies to modeling in general, and hopefully this tutorial is going to be of some benefit to you. So let's get into it. I'm not going to explain much here. I'm just going to model it. Okay, and there we have it. So we've just modeled the part. We did all sorts of different constraints. We mirrored, we did a ton of different things, and all of them have to do with constraints. So again, this was originally a user request for this part, and they found it very difficult to model. And also I was seeing numerous posts recently on a Facebook forum for Autodesk Fusion that talk about the frustrations that ones have with constraints. So have no fear. Hopefully this tutorial will help you immensely. And again, I can't stress enough that this needs to be explained in a simple way. And so if you're an advanced user and you think this is too simple, please bear with us. Think about new ones who might be learning that find this frustrating. And for those that are new, if you could please consider liking this video, it really helps out our channel a lot. Please explain something that maybe you've benefited from in the comment section as well. But that will be in due time because you want to learn a little bit more of what we decided, how we modeled this part, and again, how this all relates to constraints. So I'm just going to go back in time here. I'm going to delete everything in the timeline. Just hit the delete key on your keyboard. It's the easiest way. A lot of people right click and they go delete, but just hit delete on your keyboard. You're good to go. Okay, so first of all, we're going to create a sketch. And this is one of the first things that we're going to learn. It's imperative and it's just basic math. Actually, I shouldn't say it's basic math. It's generally learned in high school, maybe some of the later years in high school. But this doesn't have to do with Autodesk Fusion in itself. This has to do with just math. And so let's talk about it. I'm going to pick the XY plane here. And let's dive into what we actually see on our screen. So on the top right, you'll see our view cube, and there we see our 3 axes. Our green axis is our Y axis, the red one is our X, and blue is Z. Now, when we look at our canvas right now, or what we actually sketch on and model on, this also has 2 axes. And again, 1 axis, 2 axes. I know it sounds weird, but that's the proper term for it. So the red line going left and right, this is our x-axis, and green goes up and down. Now, I'm just going to go undo. And again, we can go to the top left up here to undo, or just Command Z on a Mac or Control Z on a Windows computer. Now, remember, we just created a sketch on the XY plane. I'm going to create a sketch on the YZ plane, and look what we have here. We have the same red line going left and right, and the green line going up and down, or our x-axis and our y-axis respectively. But look at our top right, our view cube, and you can see that those axes have now adjusted orientation. And so this is one fundamental thing that you need to realize about sketching and modeling, is when we pick a sketch plane, this is completely different than our view cube. Our view cube refers to our 3D model, the orientation of the specific model. But when we select a plane to sketch on, no matter what angle, no matter what plane, no matter what orientation we pick that plane, you'll always see what you see on the screen right now. Vertical line going up and down, the green line, that's our y-axis, and our red line going back and forth, left and right, this is our x-axis. Those will always be. This is mathematics, and this is called a Cartesian plane. With our Cartesian plane, we have something called quadrants. So between 3 o'clock and 12 o'clock, this is called quadrant 1. Between 12 o'clock and 9 o'clock is quadrant 2. It goes around counterclockwise. Quadrant 3 is between 9 and 6, and between 6 and 3 is quadrant 4. So what does this have to do with constraints? A lot. And again, this is what you need to know. These are some fundamental things that nobody teaches you in tutorials, and so I'm happy to do it. Well, let's just go undo again, because I don't want to create it on that plane. That was just to prove something, and we've learned about Cartesian planes and quadrants. Again, this all has to do with constraints. I'm going to go back to this plane. Why, you may ask? Because I want this to be the exact same orientation as our drawing. And so I can create this on any plane that I want, but the final orientation of the part won't be the same as the drawing. And so that's why we've picked the XY plane. Now, let's talk briefly about some of the easiest constraints and what they actually have to do. When we look at this part, what do we know about it? We kind of have to, whenever we see a part on a drawing, we kind of have to break it down into the fundamental or primary shapes. And those are, in fact, are called primitives. So primitive shapes. Where are primitives? If we just go escape, or should say undo to get rid of that sketch, if we go to create, these are our primitive shapes. We've got a box, cylinder, sphere, and they get more detail, but these are the 3 basic primitive shapes that so fundamental building blocks of any type of part, modeled part out there. So anyways, when we look at our drawing, we have to break down our part into a primitive shape. So what would you call this? Would it be a square? Would it be a circle? Would it be, what would it be? Well, it's neither. It's a unique shape. And in fact, the closest shape to it, if we go to create, is something called an ellipse. When we look closely at the drawing though, this is not an ellipse. This is something completely different. We know it's not an ellipse because it has a radius on the top at 0.313 inches. And then we have a radius on the side, and it's in brackets. Well, that has to do with constraints as well. We'll get into that. Just keep bearing with us. But let's just bring up ellipse just for a moment here. And I'm going to show you something first of all with constraints. So I'm going to place the center point to this, and I'm just going to place it off to the side. Do you remember what quadrant this is? This is quadrant 1, and I'm doing it wrong here to prove a point. So bear with us. I'm just going to make a height here off to the side and a width. Now, when we look at this shape, you can see that it is a unique shape. This ellipse kind of looks like an egg. But interesting to see that Fusion has added two other aspects to this drawing, sketch elements. Do you see what they are? Well, here they are. We've got a horizontal line going left and right, and we've got a vertical line going up and down. These lines are also broken. They're actually called construction lines. Now, these two lines, believe it or not, are constraining the shape of the ellipse. Constraints are just elements that control or hold together your overall shape. And this is just a very simple example of it. Now, when we look at these two lines, you'll see that there's one special symbol on the inside, and it's right here. If we click on it, you see on the bottom right of our screen, it tells us what kind of constraint that is. And it's saying that this line, as we click on that symbol, the line turns blue, the symbol kind of is highlighted, and this is saying that that line is constrained vertically. So the whole line, we're not talking about a point here, although the symbol is at the center of it. It's not referring to the point, it's referring to the entire line, and it is vertical. What does vertical mean? One way of remembering what vertical means is I think of basketball, and sometimes when we say, hey, that basketball player has an awesome vertical, well, it means that they've got a really good jump or height to their jump. And that's the up and down direction, right? In other words, it is our vertical direction. But what other axis does this go in line with? Well, it is parallel or in line with our y-axis, the green line on the screen. So in other words, this constraint right here is very simple. It's saying that this line is just going to be perfectly up and down. It's constrained vertically. However, you can see that we can grab the center point and still move our sketch all over the place into each quadrant, no problem at all. And so this part or this sketch element is not constrained to anything in particular. Now, when we look at this too, I'm just going to click on that constraint and I'm going to hit delete on the keyboard. And you can see in the bottom left of the screen, the keyboard inputs are shown. But now look what happens. I'm going to grab this outer point right here, and you can see that our part is no longer constrained vertically. This line is no longer constrained vertically. I can grab this and I can move it in all sorts of different directions. So in the manufacturing world, this is not good. If we can accidentally, if we think that we've created this sketch to a certain dimension and then accidentally move it just even a fraction of an inch or a millimeter, then it might scrap our entire part. So the whole idea with manufacturing is we want to make our parts, our sketch elements, perfect as we can do in a design. And then when we send it to machining, we try and match how perfect we've designed it by cutting that part as perfect as we can. In a machining sense, we can't make things perfect, but in a design sense, we can, and we need to in a design sense. And that's what constraints do. So if we wanted to make that line vertical, what do? I can just pick it and click vertical. I am going to delete this and show you one other thing. You remember, I just picked the line first and then hit the constraint. I'm going to pick the constraint first and click the line. It does the exact same thing. So we can go back and forth, no problem. I'm going to delete this. One other thing I'm going to do. I am going to go back here and you remember it says horizontal vertical. So I'm going to pick this horizontal line. Remember, right now, this can still be moved, but I'm going to pick the horizontal constraint and select this line, and look what happens. Now this line is constrained. It's no longer constrained to the y-axis because remember that's vertical, but this is a horizontal constraint. So this will always be parallel to our x-axis or our red line over here. So this is looking great. Now, here's a question. I'm just going to draw another line over here, and I'm going to draw it on approximately a 45-degree angle. Now, we have to imagine, in fact, let's not even imagine, I'm just going to draw this and I'm going to call it 135 degrees. And this is going to be I'm going to turn it into a construction line. But you can see that this line can go above this is 135, but yeah, it's always going to be 135. I would have made it 45, but that's okay. Let's just, we're picturing 45 off of this line right here, our x-axis, but we're looking at this blue line right now. So I'm going to grab the endpoint. The one endpoint is constrained to our origin. We're going to get to that. It can't move anywhere, but this one can. It can move in length and it can move in position. It can move all over the place. But let's just say if I have the line below this 45 degree and I click on horizontal vertical, which axis will this line go in line with? Will it be snapped to the x-axis or will it be snapped to the y? Well, let's click on it and see. You can see it's snapped all the way down to the x-axis. Well, why? Because we've got this 45 degree line right here. Usually we have an imaginary 45 degree. So this is saying if this line is, below 45 degrees, it's going to default to our horizontal axis. If our line is above the 45 degree mark, we're going to snap it and it will snap to the vertical axis. So this is constraining this particular line. I am going to delete that and our imaginary line over here. And you can see it created actually an additional construction line to constrain the line that we just created, to put an angle on it. Great. Okay, so let's go back to our egg shape over here. Now, we want to, when we look at this egg, we can see that it has 4 sections to it. It's got one section here, another section, another section, another section. So when we look at a part on our drawing, any type of part, if we can see it in different sections that are perfectly the same, if we were to mirror this one over to the next, they're exactly the same. And if we mirror these 2 sections down to the bottom, well, they're exactly the same as well. So if we can do that with any kind of part that we're looking at, then we want to kind of design it with the center being the foundation point, the bullseye, or in mathematical terms, we call it the origin. So we want this point to be snapped to or constrained right here. Remember, this is our y-axis and our x-axis, quadrant 1, quadrant 2, quadrant 3, quadrant 4. If we can match this part to this bullseye right here so that the quadrants are all the same, then we're laughing. So how do we constrain our center point to our origin? Well, this is simple. We're going to move on to the next constraint in the series, and this is called coincident. So note what it says: constrains the position of 2 points or a point in a line or curve together. So we have 2 points. We have a center point and we have an origin point. So let's pick this. I'm going to select that, and you can see it says on the bottom right, sketch point, and our point turns dark blue or maybe a navy blue color, right? Now let's pick the origin and look at that. Now our point turns black. If we click on it, you can see we've got a coincident constraint that is locking that point to the origin. So this is great. Now let's move it. Now look at what we've got. We've got this part. It's wandering all over the place. So we can try and constrain this line, either vertical or this line horizontal, in order to lock our part right down. Now, we could just click on that, click on our line, and it turns vertical. But I'm going to show you one other thing. Sometimes this frustrates Fusion users to no end, but you'll love it once you understand what's happening. If I grab this line and make it vertical, look what symbol automatically shows up. See if I can bring it up here. No, it's not letting us. I just saw it. It disappeared. Okay, now it's dancing all over the place. There we go. Do you see the symbol right below the 0.25? There is our vertical symbol right there. It's beautiful. So I've just locked it in. And now this line can only move vertical. I can no longer move it. Oh, I've just broken it actually. There we go. What happened? There we go. It didn't actually show up before, but now it does. Now I can just change the height, and here I can change the width of it. But interesting enough, this line is also constrained. Why? Well, it is assumed when we've got 4 lines like this that they are all perpendicular of one another. And that corresponds to another constraint, but we don't see it on the screen. If I in fact try and move this line, look at what shows up below it. You do see that, there we go, the horizontal constraint shows up when I'm moving it. And so it's just saying that this line is automatically constrained horizontal. Sometimes that happens with Fusion, and particularly when lines cross like this and we have 4 equal sections, well, one is going to be perpendicular to the other. Now this still doesn't help us. We've got an egg shape and we're supposed to have not an egg shape, but what we see on our drawing. So let's encapsulate everything here and we're going to hit delete. And we're going to start right on over again. So let's first of all start with those 2 governing lines, we might say, or constraining lines. So let's start out with a line here. I'm just going to create it below our origin. And let's just start off with one element at a time. So this line is going to correspond to the width of our part. Now, if we look at the drawing, we see the width is 0.881 inches. But we want to constrain this line. And actually, if we look here, there's 2 lines. Sometimes my mouse does that. It clicks twice when I don't want it to. So that sometimes that frustrates ones too. Now I only have 1 sketch line as it shows on the bottom. But I would like this line, the center point, to be perfectly placed on our origin. So how do we do that? Well, let's go up to our constraints and we're going to look at our midpoint constraint. Let's click on that. And here it's very simple. I can pick one or the other. Doesn't really matter. Let me show you. I'm going to pick the line first and then the origin. There, it snaps into place. I'm going to go undo just for fun. And I'm going to pick the origin and then our line. It does the exact same thing. So again, a lot of these constraints, you can go, either pick the sketch element first and then the constraint, or the constraint, then the sketch element. You're good to go. Anyways, let's turn this into a construction line because it's not, again, the final sketch element that we want to preserve or we want to turn into a 3D part and do a 3D model. So we're just going to use this as a reference line. We're going to single click that and I'm going to hit X. I could also go up here to line type and there's our construction right there. So now we've got this line because it's at the center. Or constrained to the center point. You can see as I move the line in whatever direction, it's equal and opposite on the other direction. But I want to make this horizontal now. This is going to be our horizontal reference line. So how do I do it? What do I do? Again, we go up to our constraints, horizontal, vertical. We're going to click on that line and there we go. Now this is not yet fully constrained. Let's look at our sketch over here. Our sketch shows a little pencil beside it. This means it's still in edit mode. What needs to be edited? It needs to be further constrained. And what needs to be constrained? It's the length of it. So you might not think of dimensions as constraints, but that's exactly what they are. And so let's press D for dimension. Most of new users of Fusion will pick the endpoints. They'll pick one endpoint, the second endpoint, and they'll call this what it needs to be, in this case 0.881. I'm going to undo. Easy, much easier way. Press D for dimension, or you can always go up here, sketch dimension. Everything on the toolbar is found in the group menu below it. So if dimension isn't up here, just click on create and find dimension. There it is at the bottom. If you want it on the toolbar, hit the kebab menu. This is the kebab menu, 3 dots here, and you go pin to toolbar. So anyways, D, get used to the shortcuts. And instead of picking endpoint and endpoint, just pick the line. There you go, 1 click instead of 2. It saves a lot of clicks on your mouse when you only click once instead of twice. There we go, I'm gonna put in 881. We're gonna do the same thing now with our height. So let's do that. I'm gonna create a line off to the side. Now, maybe what frustrates ones too is they will actually create it on the y-axis, right? And they'll go like this. And they will assume that it's snapped to the y-axis, but it isn't. As you can see, it's parallel to the y-axis because a vertical constraint is applied to it automatically in this instance. But just because you've placed it on an axis or on a line doesn't mean that it's going to automatically snap to it. Remember, we want to work with perfection when it comes to modeling and design work. So we've got to snap this line, the midpoint of this line, to our origin. And how do we do that? Again, let's go back to midpoint. Boom, pick the line, pick the origin, and there we go. Now look at our line here. The only thing that needs to be constrained is our height. And when we look back at our drawing, what do we see? Our height is 1.64, so let's press D. I'm going to pick the line, and I'm just going to type that in there, 1.64. Now let's make this into a construction line. So click X is the shortcut. And then what I'm going to do too is I'm just going to place this dimension a little bit down so that it's not right in the line. Sometimes if you've got, your dimensions and you place them like this, you can't see what's going on. So just single click, drag them off to the side. There we go. Perfect. Now we've got everything locked in. How do we know it? Let's look at our sketch. You can see it's got a lock icon down there below, and everything is looking great. Now at this point, I just wanted to send a quick shout out to our sponsor, PCBWay. If you wanted to 3D print anything or get it manufactured, CNC machined, check out PCBWay. They've got fantastic services. I created a safety razor through PCBWay. You can check out the tutorials that are related to that. It was such a fun project, but they do a good job, and I hope you check them out. So thanks so much, PCBWay, for sponsoring us. All right, let's get into it now. Remember what we talked about with the ellipse before. If we can divide a part that we're making into equal sections, well, and then just mirror them to the next, well, that saves us a lot of time. We would have to put all of the different radius values and arcs and everything for every one of these, and it would take up a lot of time. So why don't we just create it in quadrant 1? And then mirror them over to quadrant 2 and then quadrant 3 and 4 later. So let's pick our 3-point arc. And I am going to snap, again, I've mentioned this in other tutorials, but with sketch tools, when we pick a different tool, it tells us what to do. And here it says place start point. So I'm going to place a start point up here. And then it's going to ask place endpoint. I'm just going to place it somewhere down there. And then it says place point on arc. So if I go in between those 2 points, you can see that it creates a small section of an arc. If I go outside of that, look what happens. Now we get this giant arc. So this might frustrate ones too, but the principle involved is just start simple. Start with one sketch element at a time, constrain it, lock it in before you move on. Anyways, there we go. I'm going to create that. And now look at what we have. Nothing is constrained. The line is blue. Blue means that it's not constrained. Endpoint is white. That also means that it's not constrained. If I single click it, it turns blue. That just means it's selected. So escape gets rid of it. I could also just click on the canvas anywhere. It also gets rid of it. You don't have to press escape all the time, but generally that's what I do. Anyways, here we go. So let's constrain this arc with what we know about it. And when we look at the drawing, what is the radius value? 0.313. So D for dimension. I'm going to pick the radius. I'm going to just apply that radius value, 0.313. Now, what do we have that's not constrained? I'm going to grab this. You can see it's not constrained in many different directions. So look at this endpoint here too. The endpoint isn't constrained, and the center point. I can move the center point. Now, interesting. When we look at the drawing, we see that all of the curves are perfectly smooth. Where they meet up with the next curve, it's perfectly smooth. And in mathematical terms, this is called tangency. So for the sake of this tutorial, to keep the definition of tangent as easy as possible, just picture a line in a curve or two curves, two arcs, meeting up perfectly together so it has a perfectly smooth transition. So let me show you something. I'm just going to go mirror over here. You don't have to do this. This is just to explain something. I'm going to pick the arc and the mirror line over here. And now look at what we have. This arc and this arc, if I click on it, you can see, if I just hover over it, actually, you can see that their center point turns white. Our center point turns white. But let's move this. And as you can see, if I move past the center line, the two arcs become sharp. If I move the opposite way, you can see that there is a valley going on. So how do I make them perfectly smooth together? Well, look at the center point. I'm going to zoom in here. As the center point gets closer to the center line, our reference line, those two arcs become perfectly smooth, or how they meet up together is perfectly smooth, or in other words, they become tangent. So what's the secret of tangency? Well, I'm just going to delete this element right there, and I'm going to grab this center line, and I want to make, or I should say the center point, and I want to put this center point, I want to constrain it to this line right here. If it's perfectly on this line, it means that it will be perfectly smooth or tangent to the next curve over here. So let's do it. What constraint do you think I should use? Well, Fusion is smart. If I click on the center point, all of the constraints that are unavailable to us, well, they disappear. They don't disappear, they become hidden in our constraint menu. So the ones that are available, we have vertical, horizontal, we have coincident, we can lock it, which I recommend not using this if you can avoid it. There's particular circumstances that we can. A lot of people love this, but it gets into trouble very quickly. So we'll talk about that. There's some other tutorials. I'll talk about this later, not in this one. We've got the midpoint. We don't want that. We've got collinear and we've got symmetry. So which one do you think it is? How can we lock this point to this line? I'll give you a couple seconds. Did you figure it out? Well, let's click on the point, and it is coincident. So again, if we hover over coincident, it tells us constrains the position of 2 points or a point and line together. So let's pick the line. Boom, there we go. So now our curve here, our arc is black. It will match perfectly over to the other arc on the mirrored side over here. But the one thing that is in question is our endpoint. That's the only thing that can move. Again, I've mentioned this in other tutorials too. If we're ever wondering, you know, what is the element that is not constrained, just try and find it. It's either blue if it's a line type, or it's white if it's an endpoint, and click it and move it. Now we can see that this arc is not constrained fully. So let's get into it. Let's get another 3-point arc, and I'm going to click on our endpoint and over here. And now it's asking for placing a point on an arc. So here's an interesting thing. As I move the arc close to being perfectly smooth to the other arc, look what happens to it. Look at the little point over here. You can see a symbol shows up, and it's a circle with a line on top of it. What constraint do you see on the top that has a circle and a line on top of it? Well, I'm going to press escape, and we're going to go up to the top here, and look at this. Tangent. This is the tangent constraint. So it's saying when we've just created that arc and to our endpoint over here, as we bring it approximately in line with it, it will automatically create a tangent constraint for us. Fusion is smart that way. So I can just click, and then look what happens. If I click on that symbol, tangent constraint is in the bottom right. Everything is amazing. So this is great. I'm just going to delete this line, and let's pretend that I didn't do it properly. I didn't see the symbol. Let's say I've got a extended arc over here. Well, if I want to make it tangent, let's click the tangent constraint, and I'm going to pick the arc and the arc. Now you can see it's done something a little bit crazy here. It's gone way, way past, and I could try and fix this, although I don't think it's going to let me. Sometimes this happens when it assumes that we want to do something else. Fusion is smart, but you can see it's gone the opposite way. But if I pull this, there, I can control it a little bit more. There we go. So we can always apply the tangent constraint to it, but it's easier to try and lock it in, just with the two elements themselves. But now look at, as I click on our arc over here, if I change this, look at the center point. There's the center point. I'm just going to change the value or the shape of our arc, or our radius value, I should say. As we move this, you can see our radius value changes. But look at the center point. So the center point, remember with tangency, this element right here, if it's going to match up with the other arc on the other side, this center point needs to be resting on our red line or our x-axis. So remember how we do that? Let's try with the coincident constraint and see what happens. So I want to pick this center point, and now it won't let me pick the red axis. Why? Well, the red axis here, our x-axis, it's not actually a line. It is an axis. It's kind of in space. It's part of the Cartesian plane, but it's not doing anything for us. These are physical lines that we can work with, and we can work with a point or a line. So how do we constrain this point then in line with this line or in line with the origin? Well, let's pick horizontal vertical. And here we can pick the point and we cannot pick the line. It won't let us pick the line. The line is already horizontal and we can't really pick it. We can only pick that on its own. But if we want to make this point horizontal to the line, think of something else. What else is perfectly horizontal, or what can we make it horizontal to? Well, this point is going to be perfectly in line with the red axis or the x-axis and our origin too. So we can actually pick this or the origin. Which one would you rather pick? Well, I would rather pick the origin because this is, again, kind of the fundamental piece of information that's never going to change on any of our sketches or anything. It's our origin. It's the bullseye. It's the, what we revert back to. So I'm going to pick that. And you can see now we've got a horizontal constraint underneath our point. And it also, as I hover over it, look at the origin. The corresponding horizontal constraint matches up. So this is saying that those 2 points are perfectly horizontal from one another. As I do so, this arc also turns black. It has nowhere to go. It's perfectly constrained. Now we've got this shape, which we know if it continues on this side, it's going to be perfectly in line or perfectly smooth, perfectly tangent. Same with this sketch element over there. So what do we have to do next? Well, we're going to go to mirroring. And as we go to mirror, I am going to pick these 2 elements right there and our mirror line. We're going to pick that one right there. So I'm just going to go cancel and show one other thing. If I go mirror, let's say that I had 100 different sketch elements here that were all connected, and instead of clicking one at a time, you can actually pick what's called a chain. So any that are tangentially connected, or in some instances are not tangentially constrained or connected, if we double click it, it will pick that entire chain. So there we go. You can see it saves a lot of steps. I'm going to pick the vertical line right now. Go OK. Now, what do we see? Mirroring is actually another term for constraint. And what constraint are we referring to? Well, go up to the top and we hover over the same symbol here. And what is it? Symmetry. And again, I can just click on the symbol itself and it says symmetry constraint. So this is picking every single point, every single arc, every single feature, and it's actually mirroring it to the other side or making them symmetrical mirrored image. And so, yeah, those are kind of the same terms in the real world, symmetry and mirroring. Let's go back to mirror. I'm going to double click this. It's not picking the entire chain because Fusion knows that we created this in a different operation. So I'm going to double click that chain as well. Now it's saying that 4 objects are selected. Mirror line is going to be right there. We're going to go OK. And now we've got the exact same shape that we've looked at on our drawing, and everything's perfect. Now, what else is missing right now? Well, it is the center points of our holes. Now let's talk about this because this is also something, a fundamental skill that many don't know of. I could finish the sketch right now. Let's go back to our ISO view. I'm going to go back to extrude. We could also press E for extrude, but as we do so, it picks the closed profile that we've just created. Closed profile means everything is connected. There's no gaps, there's no holes, there's no spaces, there's no anything. It's completely closed off. Another term for it is a watertight profile. That's because if we pour water in it, it wouldn't be able to go anywhere. Anyways, we're going to just drag this down. I'm going to type in the height minus 0.45. And here we're going to create the holes for the points, or the center points for our holes on this. Now, you might be asking, well, why did I go in the negative direction? How come I didn't go in the positive direction? Well, let's try that. Did you know that we can actually create everything in one sketch? And we're going to get back to constraints in a second. But if I turn on the sketch, look at where the sketch is actually on our part. It's on the bottom. I would rather the sketch be on the top of the part. So I'm going to go back to our extrusion here. I'm going to double click and I'm going to go the opposite way. To go opposite, we just put a negative. There we go. And now you can see the sketch is still visible on the top. We can make it visible, we can turn it off. We can make it visible, we can hide it. So we've got that. But what I'd like to do is put the center points for our two counterbores. We've got the center point. This is physically selectable. That's one benefit of also creating our part around the origin, but we're missing the points for our counterbore. So how do we go back and edit the sketch? We just double click our sketch in the timeline or right click edit. Some feel that right click editing is easier as double clicking. Sometimes their mouse doesn't want to double click. Anyways, I'm going to go create, I'm going to go point. And now what we can do is I'm just going to create this on our vertical line, our y-axis. And I'm going to do the same thing over here. I'm going to create 2 points. Now we want to make these 2 points mirrored from each other. And because I have snapped them to the line, or I've clicked on the line, it's actually automatically created a coincident constraint. If it hasn't done that, let's just go back to our point. If I put the point slightly off to the side, and in fact, I'm going to prove something here. I'm going to zoom in really, really far. I'm going to make it look like it's on the line. And in fact, as I zoom out, look at that. It looks like it's on the line, but it's not on the line. It's white. And so it's not actually constrained. So to constrain it, I'm going to go back to coincident, click our point, click the line. Now they're locked together, but I want to make these mirrored or symmetrical. How do I do it? Let's go to symmetry. Click on that, hover our mouse, it tells us what to do. Select sketch objects. So sketch objects are the tangible sketch elements that we want to keep. They're not referenced. They're the sketch objects. So I'm going to pick the point. Then I hover my mouse, it says select sketch, second sketch object. I'm going to click that, and then it asks for a symmetry line. And this is kind of the theoretical line, or it's not really that tangible. Again, it could be if we wanted it to, but we're just going to pick this x-axis right there. And now you can see as I move one in, you can see they are symmetrical to each other. So I'm just going to move this out. Doesn't really matter, actually. We can leave it on the inside. But look at the distance between those holes. Do you see? 1.25. So I'm going to pick those 2 points, move it on over, 1.25. And now, is everything constrained? Yes, it is. Sketch 2 is fully constrained. Everything is looking great. And as we look at our drawing, there's a bunch of assumptions that we make, and these are okay to make. And as we can see, it doesn't tell us that it's perfectly in line with the y-axis. There's nothing that says it on the drawing, but in this case, we assume that it is. When it looks like it is, generally it is. If it isn't, that's when we'll see a special note, or we'll see another dimension saying that it's going to be a certain distance off of the center line. But we can see that on the drawing, we can assume that those holes, the counterbore holes, are in line with our y-axis on our sketch plane. So there we go. Let's go finish sketch. I'm going to go back to our ISO view over here. And you can see there they are, 1 and 2. So let's go to our hole tool. And I'm going to create this hole first of all, the center hole. This is just going to be it's going to be simple hole tap type. This refers to all sorts of different things, but just keep it simple. We're going to type in the diameter. You see the diameter, it says 0.375 through. So let's do that. Instead of going okay, we're going to go, instead of distance, let's just go all, and that will put the hole all the way through. Remember, if it's only going that and we go again all, it will go completely through our part. Now let's go back to our hole. I'm going to pick these two where our counterbores are going to be, and we're going to add a counterbore. Now I could put in all the values, and these just correspond to, for example, this dimension. If we follow the line, this is referring to the total length or the depth of the extent of our hole. This refers to our counterbore diameter. That refers to our counterbore depth. This refers to a tip angle. Why is there a tip angle there? Because Autodesk Fusion is a software for manufacturing. And how do you put a hole in a part? Well, you drill it. And so most drills have this as a tip angle, 118 degrees. And Fusion is again made to make all of our sketching and our modeling perfect. And so if our drill has a different angle, we would put that there. It's called a tip angle in this instance, but it's the same. And then here's our diameter through. So we could adjust this to our drawing. However, here's a cool thing. I know that a bolt or a screw is going to go into those counterbores. So I'm going to go clearance. As we go there, it asks for the type of fastener. So I'm going to change this to a unified. This is what's used in the United States and metric in the rest of the world. So let's pick unified. There we go. Socket head, we're going to pick socket head cap screw, and the size is actually going to be a number 8. I just know that because I've produced this tutorial 4 times already and I've had to delete them. And so I spent a lot of time making these, believe it or not. And if you benefited at all from this, please consider liking and subscribing to our channel. We've got a bunch of tutorials that many have expressed their appreciation for, and that's all we ask. If you've benefited, please let us know. If you don't, if you dislike what we're doing and you think that this is too basic or something, you don't like me or my voice or something like that, we'd rather hear from you and let us know if we can change something than you know, not liking our video or disliking our video. That doesn't really help us very much. So please help us. If you have constructive criticism, we want to hear about it. Anyways, there we go. Distance, we want to go all the way through. And now we've got these counterbore holes right there. So we're going to go OK. Let's hide the sketch right now. Hide the individual sketch rather than the entire folder. If we hide the entire folder, all subsequent sketches will also be hidden, which doesn't help us. So just hide that single sketch right there. I'm going to go back to ISO. We finished our part. So in a bunch of our tutorials, many of you have asked how I can move the part around so freely and so easily. Well, that's because I use a 3D connection, and I have some really amazing news actually. I was able to contact 3D Connection. We've teamed up together, and there is a special promo code, 10% off of 3D Connection products. If you're interested, I think they're great for new users and advanced. So check out the link in the description below to be able to benefit from this unique deal. 3D Connection doesn't always have deals like this, so this is kind of a unique opportunity, but we'd like to send out our thanks to 3D Connection as well. You make awesome products. Thank you. There is a ton that we've just learned in this tutorial, and again, we hope that you've benefited from it. Before we finish, I just want to send out a huge shout out to our YouTube members and Patreon members. We have a growing community both in YouTube. Membership is paid, and we really appreciate it. It's a way that one can support us, but you also get some perks as well. There's some special videos, behind the scenes videos that I make. On Patreon, there are a ton of perks, and I love Patreon. It's treated us very well. There's files that you can download, there's behind the scenes videos, there's extra goodies, there's technical documents that you can download, there's all sorts of different things, wallpapers as well. And so if you would consider becoming a member, we would love it. That's especially if you love our channel. So, and these are all the ones that have helped us, that are currently supporting us, ones who have bought us coffees as well, other support that you have given us. We truly appreciate it. So I missed this earlier, but wanted to make sure that I addressed it, and so sorry it's at the very end of the tutorial. But we're going to talk about over-constrained sketches, or another word for them is driven dimensions or reference dimensions. So let's go back to our sketch here. And it had to do with this arc right here. So you may have noticed at the beginning of this tutorial, when I sketched and modeled this entire project for your reference, that I included a dimension right here, and it's actually on our drawing as well. You'll see that there's a dimension in brackets. Well, why? Well, just to explain one other thing, we have our dimension right here. It is our radius value of 0.313. We know that the center point is locked. This arc right here, when we lock the center point to it, it became fully constrained. Well, why? And this is one thing with math as well, is that if we know two elements of 3, well, we know the third. And so in this particular instance, this arc, we do know a bunch of different things. We know its start, we know its end, we know its center point, we know its arc value, its radius value. And so we know all the information, and Fusion doesn't need any more information. In fact, again, this doesn't have to necessarily do with Fusion itself, but we have all the information mathematically to lock in or constrain this arc and it can't go anywhere. If we change anything else, well, then it will change. But in the meantime, there's nothing else that we can grab. We can't grab these endpoints. We can't change the radius value. So if I press D for dimension and I select this arc, you'll notice it says 1.385. But if we click, we get this over-constrained sketch alert right here. So do we want to over-constrain it? Well, no, we don't. Rather, it asks create a driven dimension instead. And so a driven dimension is just another name for a reference dimension. And as we create that driven dimension, you can see it is in brackets as well. Now here, this is very interesting because if we change anything else on our sketch, this will update. And so these are called driving dimensions. This one, our overall height, our width are all driving dimensions, and I'll prove it to you. I'm just going to change this to 0.3 and look at our driven dimension, our reference dimension. There we go. So that automatically updates. I can change this as well to whatever I want, 1.5. There we go. So you can see that this updates constantly depending on the driving dimensions. So sometimes you get that alarm, and understanding why it's happening can help you to not be frustrated with Fusion. Again, this is more so relating to mathematics than Fusion itself, but reference dimensions can come in very handy when we're doing design work, and hopefully you'll love them. And so on our drawing, we see that that's a reference dimension. It's actually not needed to complete our part, but then creating the dimension on our screen right here, it just verifies that those two dimensions are the same, and it means that we've modeled our part correctly. So that is what is referred to as driven dimensions or reference dimensions. So we hope that you've benefited from this tutorial. If you have, please comment below. And if you wish, please stick with us. We hope that you'll continue to learn with the Learn It channel. So see you at the next tutorial. Take care.